This is a run-through of the investigation for exponential functions about bacterial growth. It starts with the pretest problem, where the pretest problem asks you how long would it take for a population of bacteria to double if it grows at 4% a minute. One of the things that makes this problem challenging is that it doesn't tell you how much bacteria there is at the beginning. And that sometimes confuses people. It's like, how can you figure out how much it's growing, how long it takes to grow to a double size if you don't know how much you start out with? In the end, you'll find out that the reason why they don't give it to you is because for exponential functions, it doesn't matter how much you start out with. The length of time to double is always the same. So, first thing it says is, let's start with a number instead of not having a number. So the number we're going to start with is 10. So we're going to put 10 as the initial amount of bacteria. And then in number 2, it asks you to use your calculator to figure out the amount of bacteria at time equals 1, time equals 2, and time equals 3. So let's think through that. How do we figure out the amount of bacteria at the next point in time? Well, we know that it grows 4%. So how about if we first figure out what's 4% of 10? So we're going to multiply 10 by 0.04, that's 4%, and we're going to get 0.4, okay? So we know that the amount of growth is going to be plus 0.4, and so we're going to add that amount of growth to the original amount, which is 10, and so at x equals 1, which is time equals 1, we're going to have 10.4 bacteria, okay? And then so the next minute, we're going to have a 4% growth on top of that. Let's use the calculator to figure out what is 4% of 10.4, and we get that it is 0.416. I wrote it there, okay? And if we add the 0.416 to 10.4, then we're going to have the next amount, which is going to be 10.816. And then if we want to see how much we grow the next time, then we multiply by 0.04 again. And we're going to get 10.816 times 0.04. And we'll get 0.43264. 0.43264. And if we add that to the original amount, which is 10.816, then we get 11.25 about, okay? You don't need to write all the digits. That's about enough, okay? Then it says it asks us how we calculated the y for x equals 2 and x equals 4. And basically what we did was we multiplied by 0.04 so that we could find out how much the growth was, and then we added that to the original amount, right? That's pretty much our procedure. And then in 4 it says, if you used a combination of multiplication and addition to find the new values of y, can you try to find a way using only multiplication? So let's take a look at the way that we calculated our initial numbers. We had the original number of 10. We took that number 10 and we multiplied it times 0.04 so that we could find 4% of that, and we got 0.4. Then we took the original number itself, and then we took the 0.4 and we took the original and we added the numbers together, and then we got 10.4, right? If we wrote that out in an equation, we would write 10.4 equals 10 plus 10 times 0.04. Now what if we factored out a 10 from both of those? We would get 10 times 1 plus 0.04, which is equal to 10 times 1.04. So basically, instead of multiplying by 0.04 and then adding that value to the original number, we could just make a new rule, which is just to take the original number, multiply it by 1.04, and then you get the new number in just one step, right? Okay, let's move on to number 5. Number 5 says that we're going to enter our table, which have the numbers 0, 10, 1, 10.4, 2, 10.816, and 11.25. So we're going to put those into Desmos. The way we do that, let's see, we're going to move this out, move Desmos in. Okay, the way we do that is with this plus sign, we make a table, okay, and then we just type the numbers in there. I've already done that here. You see I've typed in 10, 10.4, 10.816, and on the left side I put 0, 1, 2, 3, okay? And then I can already see that my numbers are plotted here, right? Okay, let's see what the next step is. It says to type in the expression y equals kr exponent x and convert both k and r into sliders. So let's do that. We're going to do plus expression y equals kr to the x, okay, and convert both into sliders. So now we have an expression which, or we have a, it's right here, by the way, this line here. Let's change the color to something more. Blue, maybe. Okay. Now we're going to start adjusting our k and our r, okay, and see what k and r do, okay. Let's see, what does the instruction say? Adjust the k slider. Okay, the k slider. We're going to adjust the k slider. What does the k slider do? Okay, well, it seems to make kind of the slope or inclination of the exponential function change, doesn't it? Make it steeper, make it less steep. Okay. More specifically, let's see, when it's 0, I'm going to change it to 0. It is flat. Okay, so when it's 0, it's flat. When it's negative, ooh, it like slopes down. And when it's positive, it slopes up. Right? Okay. Now just the R slider. What does the R slider do? Describe its behavior when it's equal to 1, when it's less than 1, and when it's greater than 1. Okay, R slider. So R slider. Oh, interesting. So when the R slider is 1, oh, it's a flat line. Okay, when R is less than 1, let's see, less than 1. I don't see it anymore. Oh, there it is, there it is. Less than 1. Okay, when R is less than 1, it slopes down. And when R is greater than 1, slopes up. Okay? And when R is negative, the thing just disappears. So when R is negative, no graph. All right. Number 9. Now adjust the k and r slider so that you have a function going through each of your points. What are the values for k and r? Okay, let's try that. That looks too steep. Okay. Make it a little bit bigger. Let's say, let's do 1.1. Too much. 1.05. Still too much. 1.04. Oh, perfect. Perfect. So, k equals 10, r equals 1.04. K equals 10, r equals 1.04. Number 10. How is the final amount for the r slider related to the original problem? Well, that looks familiar, doesn't it? 1.04, that was, 1 plus the 4%, right? That's how it's related. It's the growth rate. How is the final amount for the K slider related to the original problem? Okay, K equals 10. 10 was the starting or the initial amount. The initial amount of bacteria. Okay, how can you make the starting amount of bacteria larger or smaller? Oh, well, all we need to do is make K bigger, right? We could do K equals 11, and that will be a larger amount. Okay, we could do K equals 9, it would be a smaller amount. Okay, so we just adjust K. Okay. If you go back in time, for example, 10 minutes ago, which would be x equals negative 10, 50 minutes ago, which would be x equals negative 50, and 100 minutes ago, which would be x equals negative 100, what happens to the amount of bacteria? What value is it approaching? Okay, so we're going to go back to our original values, K equals 10 and R equals 1.04, and then we're going to look on this graph at values like x equals negative 10, that would be right here. So the amount of bacteria is 6.756 at K equals negative 10. 6.756. Okay. What about 50 minutes ago? 50 minutes before the experiment started. The amount of the bacteria is about 1.4. And what about 100 minutes ago? 0.197, or about 0.2. Okay? All right. So what value is the function approaching? Well, we can see if we go even farther to the left that it's approaching 0. Okay? Do you think that the function will ever touch the value 0? Okay? No, I don't think so. Okay? And the reason why is it looks like an asymptote. Okay? Or maybe a physical reason why is, think about what this means. So, like, if we had 10 bacteria, a quantity of 10 bacteria at x equals 0, right? And we go back in time, are you ever going to get to the point where there was no bacteria, right? Have you ever thought about what happens when you have no bacteria? What's going to happen after 10 minutes? Are you going to have any bacteria then? Normally, when you don't start out with bacteria doesn't grow, right? You have to have some bacteria there to start the growth, okay? So that's a physical reason why maybe you would not expect to, when you go back in time, to find a quantity of 0, okay? Okay, number 15. Finally, add the following variables, C and D, to sliders to the equation. So the C and the D go here and here, okay? And then it asks, what do the C and D sliders do? So let's see. So we're going to put in C here, C plus, and then instead of just X, we're going to have parentheses X minus D. And then we're going to make sliders for those. Okay, and then so first we're going to say, okay, what does C do? That's interesting. C moves the whole function up and down without really changing the shape, right? What does D do? Not very obvious what D does. Let me back up a little bit here. Do you see what D does? D moves it left and right without changing the shape. Okay, so let's write that down. So here I've noted that C makes the function go up and down, and D makes it go left and right. Okay. If C equals 5, then what is the horizontal asymptote for the function? Okay, and what is the amount of bacteria when x equals negative 30 in this case? Okay, so let's say when C equals 5, I'm going to set the D to 0. Okay, and when C equals 5, what is the horizontal asymptote in this case? Okay, so I'm going to go out to the left a little bit. it looks like the horizontal asymptote is around 5. And so it says, what is the value of the function at x equals negative 30? It is about 8.12. Okay, so I'm going to put y equals 8.12 at x equals negative 30. And when c equals 5 and d equals 0, the horizontal asymptote is y equals 5. Okay? Finally, at the end, what is the effect of adding the negative sign in the exponent as below? What is happening to the bacteria in this new graph? Okay. Let me show you what that looks like. It says we're going to add the negative sign here. Okay. So I'm going to put here a negative sign to see what happens. Whoa, did you see that? Let's take it out again. Okay. So the negative is flipping the graph. Now what if we have a d that's not 0? Let's make a d that's not 0. Now let's flip it. Oh, interesting. The d value here is about 10. Now watch this line right there. Look at that. So it flips it around the axis at x equals 10, right? So we could say, what is the effect of adding the negative sign? What is the effect of adding the negative sign? The effect of adding the negative sign is we reflect it. We reflect it about the line x equals d. What is happening to the bacteria in the new graph? So in the new graph, where we have negative here, the bacteria is decaying. Okay, so maybe it's like you're taking antibiotics or something. So bacteria is decreasing. Okay, that usually never happens, right? All right, that's it for this section.